Okay, so far what we've done moles to moles, where we utilize the numbers that were out in front, all right, and those tell us the number of moles. That 3 moles of aluminum bonds with 3 moles, I'm sorry, I said that wrong, didn't I? 4 moles of aluminum bonds with 3 moles of oxygen, and that'll make me 2 moles of this Al2O3. Now what we're going to do is we're going to do the same kind of idea, but instead of working with the moles, we're going to work with mass, and mass means grams. So I'll get rid of this, and according to your notes on mass to mass, we're given an equation of N2 plus 3H2, and that's going to form 2 NH3s, or ammonias. All right, then it says, well, how many grams of NH3? So we want to know X grams, not X moles, but notice it's X grams this time. Will be formed from 5.40 grams of H2. So I get 5.40 grams of this guy. So this time we're doing grams of this to grams of that. All right. Now, because it's grams, I got to add another piece to this, which what I got to do is I got to do the molar mass of each one of these. So I'm going to do it right underneath it. So I really have 2 hydrogens times his mass is 1, and then all of that times the big 3 that's out in front. So that's 2 times 3. That gives me 6 grams of H2. And on the other side, I got 1 nitrogen, which is 14, plus 3 hydrogens times his mass is 1, and all of that times 2. So if I do that one, that's what, 14 plus 3, so that's 17 times 2, so that's 34 grams of that one. So now this time, instead of using the numbers out in front, which were moles, now I'm going to use these grams. And it's really that 6 grams of hydrogen will make for me 34 grams of NH3. Right? So again, this came from the balanced equation. Now I go to the question. Well, I don't have 6 grams of this, I really have 5.4. So 5.40 grams of hydrogen will make X grams of NH3. So now all I gotta do is cross multiply. 6 times X equals 34 times 5.40. Divide by 6 on both sides to get X by itself. And X ends up equaling 30.6. And that's grams of NH3. All right, I'm going to move this down just a little bit so you can see it. There it is, 30.6. Okay. So what does this tell me? It tells me, well, according to the balanced equation, 6 grams of this will make 34 grams of that. But I don't have 6 grams, I have 5.4 grams. Well, if I have 5.4, how much of that is going to be made? Well, it's 30.6. That's what we just found out. All right. And it's all because of this ratio of 6 to 34. All right, well, let's go. Let's do another one. We're still going to use the same balanced equation. So I can erase my blue stuff up on top. All right, it says find the mass of nitrogen. So we want to find X, and mass is grams. So X grams of nitrogen to react with hydrogen, gobs of hydrogen, so it doesn't tell me how much, just a whole bunch of it, to form the 30.6 grams of this. So I'm going to make 30.6 grams of NH3. We want to find out how many grams of this I need. All right, so we're still going to use this molar mass, but now I need the molar mass of this one. So I'm going to go 2 times 14, and all of that times the big number out in front, which is 1, which really doesn't change it, but it's 28 grams. So I'm going to set up that 28 grams of nitrogen will make 34 grams of NH3. Then I go, well, I want to find out X grams of nitrogen if I'm going to have 30.6 grams of NH3 made. So from there, cross multiply, X times 34 equals 28 times the 30.6. So divide by 34, divide by 34, X is by itself now. And what do I end up with? Let me get my cheat sheet out, 25.2. That's grams of nitrogen. All right. I did at the end, so this tells me, well, if I'm going to make 30.6 grams of that, I need I need 25.2 grams of this guy. That's what I just found out. All right. And the last little piece was a thing about the law of conservation of mass. And that says whatever I really can't create matter, can't destroy it, all I'm simply going to do is rearrange it. Well, in the last one, we found out that the hydrogen that was being used was 5.40 grams to make that 30.6. So now if we take these numbers, take the 28 plus 6, well, that should be equal to 34. Oh yeah, it is. 28 plus 6 is 34 grams of that guy. And then if I take this upper part, if I go 25.2 plus 5.40, well, that's going to give me, actually I'll do this, I'll go plus, should be equal to 30.6. Yep, it is. Because according to that law of conservation of mass, I can't create matter, can't destroy matter. All I can simply do is rearrange it. And that's really all I'm doing. When it goes the other side, I still have the same matter, so I have the same mass. It's just in a different organization. I've organized it differently. All right, let's do another example. Let me erase this because, we're going to change the recipe. We're going to change the balanced equation. All right, so my recipe now is, which my balanced equation is 2 Na2O2 plus 2 H2O. That's going to form O2 plus 4 NaOHs. All right. And it says calculate the mass of Na2O2. So we want X grams, that's mass, needed to form 4.45 grams of NaOH. That's way over here, 4.45 grams of this guy. Said nothing about O2, said nothing about water, so we don't have to worry about those. So what we got to do is we got to find the molar mass of this and the molar mass of that guy. So we got to go, well, there's 2 sodiums times 23 plus 2 oxygens times 16, and all of that times the big 2 that was out in front. So if you multiply all that out, you get 156 grams of him. Then we go to this other one. It's 1 sodium times 23 plus 1 oxygen times 16 plus 1 hydrogen times 1. All of that times the big 4 out in front. That one equals 160 grams. Now you might go, well, 156 doesn't equal 160. Well, that's true because we aren't worrying about the water that's being added to this. And then there's also oxygen being added on this side. Right, so those 2 parts are in there also, but we aren't worried about those because the question isn't asking about them. Right? So I got to set up my ratio of 156 grams of Na2O2 will make 160 grams of NaOH. So that came from the balanced equation. Well, now I want to go X grams of Na2O2 will make 4.45 grams of NaOH. So from there, cross multiply, X times 160 equals 156 times 4.45. Divide by 160, divide by 160, and X ends up equaling 4.34. Oops. And that was grams of Na2O2. All right. So far we've had, moles to moles, where we took the numbers that were out in front, used those as my ratios. And in these notes, we did mass to mass. So we had to set up molar masses, and we used the mass to mass in order to calculate these. So that's what this set of notes was. All right, with that, tomorrow we're going to be doing some problems. So we'll see you tomorrow.